So we're going to go over the slope of a tangent. And we'll quickly talk about that idea of a slope of a tangent, especially of specifically a curve. So here I've drawn what looks like a quadratic. And when I'm talking about the slope of a tangent is a line that just touches but does not cross through our curve. Okay. So when we're looking for a slope of that curve, we're looking at the slope at that specific point in time. As we move along our curved function, our slope is continuously changing. Every small movement gives us a new type of slope. In fact, if you draw enough straight lines, you can make quite a nice art piece of straight lines into a quadratic. But anyways, that's besides the point. The idea here is we're going to be working with a hypothetical value of h. H being a point that is so close to where we are that it's, if rounded, is approximately 0. The idea being is that we're looking for rate of change here. Now, we're not going to get into this part. We're actually going to talk about rate of change as we originally knew it in grade 9. When we're talking about rate of change, we're talking about the change in y over the change in x. And if you guys remember, that's essentially the slope of a line is x2 minus x1 divided by, oh, that's upside down. Sorry. y2 divided by, or minus y1 over x2 minus x1. Okay? And in order to do this, we need 2 points, right, on a straight line. So that's where our hypothetical comes in. If we're at this point I've now colored blue, and we were to call that point P, our next point along there would be P plus H. And H is something that is approximately 0. It's a number a little greater than 0. You could maybe call it 0.00000.1. But if we were to round it, it's practically negligible. It's the idea of 0. Okay. So they've given us point P, and they've given us a quadratic to work with. So we are going to have our actual point, and our actual point, we can call that point 1 if we like. That'll be x1 and our y1 when going into rate of change. So when we go to plug these in, y1 will be our 9 and x1 will be our value of 3. y2, however, is a point known as, we'll call it point 2. But in this case, it's when we add a value of h to our x value. Okay? So our new x value will be 3 plus h. Okay? And that means we'll have to figure out what our another y value will be. So this will be our x2, and y2 is unknown to us. We're going to have to solve for that part. So what we're going to do is plug this x value into this equation. So we're going to find f at 3 plus h. That's the idea. So we have 3 plus h squared, which will give us 3 plus h multiplied by 3 plus h. We're left with 9 plus 6h plus h squared. So our y2 value is actually this, an equation of 9, or if we rewrite it, which we probably should, h squared plus 6h plus 9 is our y value. That would go in right here, h squared plus 6h plus 9. So this idea now that we can now find our rate of change by this being our x2 and y2, x1 and y1. So we're going to plug those values into our slope formula to find the rate of change. So let's clean this up a little. Change in y over the change in x, which is our y2 minus y1 over x2 minus x1. One of our coordinates was 3 and 9. The other one was 3 plus h, and then h squared plus 6h plus 9. This is our y2, x2, x1, y1. Okay. So we go to plug those values in. Our y2 becomes h squared plus 6h plus 9, subtracted by y1 is just the value of 9, divided by x2, which is our 3 plus h, subtracted by x1, which is just the value of 3. So now we go through a simplifying process. Okay? We can drop our brackets. We have h squared plus 6h plus 9 minus 9. So you know those 9s are going to cancel out quickly. and we have 3 plus h minus 3. Our 3's will cancel out. So these things all go away. And we're left with h squared plus 6h over the value of h. I'm going to factor, or common factor h out on top, so we have h plus 6. And the reason I've done that is because if you recall, we said that h was approximately the value of 0. Well, if I was to substitute in the value of 0 for h at this point, we have something that we cannot define. We can't divide by the value of 0. But now that I factored out the h, we've gotten rid of our variable h on the bottom of the question, and now I have h plus 6. And at this point in the equation, I can now substitute a value of 0 in for h, saying that our slope is 6 at that point. Okay? Now this is approximation for a simple example. What we're going to go into, and this is the whole idea behind this. This is a simplified version, so that we don't have to put all this thinking into it. What they've told us is we take f at a, and we have f at a plus h divided by h. So this formula, and this is the limit as h approaches 0. So we're going to take this formula, and we're going to try to apply it in this fashion to a question. Okay. So same idea of our limit as h approaches 0. Okay. And we take f at a plus h, subtract f at a, all divided by the value of h. All they've done is a bunch of the simplifying for us in this question. Okay. So f at a, and right now this is equivalent to x, but it's the same idea as f at x. Our x value here takes the place of our a in this question. We're looking for the slope when we're at the value of 3. So we're going to be plugging in 3 into this equation to find f at a, and we're going to plug in 3 plus h into this equation to find f at a plus h. So as we go through it, our f at a plus h is the idea of 3 plus h minus f at 3 divided by h. So I'm going to quickly do this on the side. F at 3, which is this equation here, becomes negative x is 3 squared plus 4 times 3 plus 1. In this case, we have negative 9 plus 12 plus 1, right? Yep, 3, 4. So f at 3 is 4. So I replace this value with the value of 4. It's a little more complex, if you guys remember from the other part. When we have f at 3 plus h, we end up at negative 3 plus h squared plus 4 times 3 plus h plus 1. A little more complex. When we go through it, we have 3 plus h times 3 plus h. Here we end up with 12 plus 4h plus 1. So there's all the simplifying we have to do on the outside. We still have our negative. This will become h squared plus 6h plus 9 plus 4h plus 13. We apply our negative h squared plus, minus 6h minus 9 plus 4h plus 13. As we simplify, negative h squared, negative 6h and 4h gives us negative 2h. Negative 9 is 13 gives us a value of 4. So this is what we replace our f at 3 plus h with. So our equation now reads negative h squared minus 2h plus 4. And remember, subtract the value of 4. All divided by our value of h. When we go to simplify, these 4's go away, and I can factor out our value of h. If we factor h out, we're left with negative h minus 2 over h. We're still working with our limit as h approaches 0. Now that I've factored out my h's, I have negative h minus 0. I'm going to substitute in 0 for h at this point. Our limit is approximately 2 in this case. Okay? That's the idea of slope of a tangent.